Okay, let's continue. I will take an example here using concerning the formula we wrote before break here. So this formula for area for circle when using diameter, and then we will check the unit conversions also, because many times they make some problems when you may calculate, for example, the area correctly, but after you get the answer, you have to convert that to the different unit, and many times that gives problems. Let's take example. We have a circle which has a diameter, let's take millimeters, 1, 2, 3, 4 millimeter. So this is a triangle, and of course we have here the area. We are calculating the area of this circle. Let's use that formula right now. We have this, I write it again here. So we have pi times 1, 2, 3, 4 millimeters square to the squared, or to the power of 2, or 1, 2, 3, 4 millimeters squared. Remember to use these brackets here, because without these brackets this squaring will go only to the millimeter. It doesn't mean that this number in the beginning of this diameter length here, I forgot what I was going to say. I meant that these brackets are important there, because after that we calculate it like this. And let's look, for example, with this calculator what we get the result, and let's take the unit conversions after that. So we get this pi times 1, 2, 3, 4. Oh, this is, I haven't used so much this calculator. These patterns are not so working well. Squared divided by 4. And we get this kind of result. One 95969.766 square millimeters. And now we want to convert this to the next unit level. So after square millimeters we get square centimeters, and in this point we always have to remember the power of the unit, or exponent of the unit. Here it is 2. So that means that every time we are converting this unit to the next level, in this case centimeters squared or square centimeters, we have to move the dot here 2 steps, and it comes from that here. Square centimeters. Mostly the error comes from the remembering that 1 centimeter is 10 millimeters, but those are the length units. Those are millimeters and centimeters. and the exponent of the unit is 1 millimeter to the power of 1. We don't write that 1 there, but the exponent is 1. So in that case, when we are making unit conversions with distance units or length units, we only move one step. The dot will or comma will move only one step. But right now we have the exponent here. It is 2, so it goes 2 steps to the left. And if we want to move to the next level, it would be square decimeters. So again, 2 steps. 119.596976 square decimeters. And again, if we want to move to next level, it would be square meters. So the dots will move there. So it will be 1.19565, etc. I'm writing the whole figure there. So this is important to notice, that the exponent of the unit tells how many steps does the dot move. Then of course we may have situation that we know the area of the circle and we need to calculate for example the diameter. Area of the circle is, let's take it, 0.89 square meters. Calculate the length of diameter. Well, it depends what would we want, what would be the result, the unit of the result. That has something to do with what we are going to do next. For example, if we want to get the result in the unit of centimeters, the diameter would be in centimeters. It would be useful to use to change the unit of the area to the square centimeters first. Let's take that for an example. Calculate the length of diameter in centimeter units. So let's do the conversion first. We have the area 0.89 square meters. Let's put some extra zeros there. After the dot we can draw how many zeros we want. We haven't done any conversions yet. But now we are moving to the right because we are moving to the smaller units. And again, the exponent is 2, so we will move 2 steps. When we move there, we will get square decimeters. And when we move here, we will get square centimeters. So the area of this circle in the unit of square centimeters would be 8900 square centimeters. These are somehow quite hard calculations in that meaning that it is not so easy to um, I don't know. For me, this is not any common knowledge. If you see this kind of area, and for example, I can't say immediately what is the size of that area in square centimeters or square millimeters, etc. I every time need to calculate that, and if you have no any common sense in this kind of problem, you may get a totally wrong from answer, and you don't see any problems there. But this simple way to make that unit conversion helps many times. And let's now take the formula. We had this formula here, and d is to be solved from this formula. So first we will multiply this equation with this 4, and when I multiply it by 4, it will move to the in front of this a in the left hand side. So I will get 4a equals pi d squared. And I am going to solve the d from this formula. This many times good advice to write the unknown so that you remember when solving the equation, you remember what are you trying to solve. It is d in this time diameter. So we have here d squared, so we have to divide by the factor of d squared. So in this time we have to divide by b. So sorry, pi. In Finnish, by the way, it is with 2 i's. B in Finnish. For example, I will show with an Excel. I have Finnish Excel. These are Finnish format. So if I need pi from Excel sheet, I will write equal, and then I will write in Finnish b, two I letters there, and empty brackets. So with this formula I get value of pi from the Excel. In the English version you use only one I there, so it is this kind of command. But in Finnish it is like this. It will tell the 2, 4, 6, is it 10 decimals or 9? Yeah. So this is the way to get the pi from the Excel. And then we divide by pi. We get 4a divided by pi equals d squared. And now we know that we know everything from the left hand side of this equation. We know a, and no, well, we didn't need anything else, but so we can calculate what is the d squared. So I will write it like this. Four times 890 divided by pi. And now we have to be careful because Actually, this is not the result yet. We get a number which has units centimeter squared or square centimeter. So this is not yet ready answer. Centimeter squared. And now we take the square root. This is one thing which many times is forgotten. So if we are calculating something where unknown is in the second power, so many times we need to use the square root later. So d equals square root of this number. And now we get it with the unit centimeter. And in this calculator I have this square root there, so there will be my answer. And this is centimeters now. And then again there may be some accuracy which we would like to use when rounding the result, but I'm not doing any roundings now because in this problem there, well, actually the starting value of the area was given only with two numbers. This first zero is not significant number, these two are, so there are two numbers accuracy. So actually in this case, two numbers are these two here, and this 6 raises this 0 to the 1, so it will be 1 1, and to get the same it is hundreds of centimeters. So if we round this, I will round it is with two significant numbers, it will be 110 centimeters. But this is maybe a mathematical way to rounding. I think in most common problems or in everyday problems, this would be rounded to 1 centimeter. It would be 106 centimeters, or in the accuracy of millimeters, so 106.5 millimeter. Sorry, 106.5 centimeters would be the value of the diameter in the precision of, in the accuracy of 1 millimeter. So this is somehow quite usual problem, this that you know the area and you need to solve the diameter. So in this case it is solved like this. Okay, and let's go to the next figure. And this is next figure is something you need in some assignment. I think it was, let's look at the assignments. There are most of these first problems are such that you may solve them by using only right angled triangles. I think first three at least, and also the fourth is you can manage it mostly with the help of right angled triangles. But for example, in this problem we need a figure, this assignment 5. It is asked what is the area of this blue area there. Let's not go to the right solution yet, but in some point of calculation you need the area of this sector of the triangle. no triangle, sector of a circle. So this part of the circle here, and that is exactly the formula which is shown in the next in this formula page. Sector of circle of radius. And these formulas differ a little bit. It depends on the formula book, how it is given. For example, in this case, the area and also the arc length, or the length of this S here, is such that in that case the angle here, it is theta in this picture, it is given in radians, not in degrees but radians in this formula book. But for example, I think in this formula here is a different formula, and actually it is given in here. There are many formulas for this area, but I think this is the most easy one, this part, because this is quite easy to prove. It is somehow very easy. There are also the formulas with using the radians in the unit of angle, but let's take that sector of circle. Let's put that in Finnish also. Sector of circle. And I will draw a big circle here. It doesn't seem like, let's take another. I hate my drawing skills. In Finnish, ympyrän sektori. It is maybe easy to understand that the words in Finnish language are written in the opposite order. Ympyrä is circle and sektori is sector. Many times in Finnish words you see the I letter in the end of the word. It is very usual. How do I get the better? Well, at least a little bit better. And the sector of the circle, it is for example this part here. And if we use the R letter for the radius of the circle, and we have the angle here which is alpha, so in this case we need to calculate the area of this part of the figure. And now if we know this angle here, or let's forget the angle first. We know that this is circle. The area of circle equals C is abbreviation of the circle, equals pi times r squared. If this sector would be half of the circle, so if I would turn this leg of the sector or this side of the sector to the horizontal position, so this would be 180 degrees. So it is easy to understand that this sector would be a half circle. So the area would be half of that circle. If the sector is quarter of the one fourth of the circle, so here would be 90 degrees angle. So this would be 1/4 or the quarter of the circle area. If we have this angle here, it may be whatever, and if the total circle here equals 360 degrees, so we may calculate the area of sector. It equals alpha divided by 360 degrees times area of circle, pi times r squared. So for example, if we have half circle here, then this alpha would be 180 degrees. And if we divide 180 by 360, we get half. So it tells us that the area would be half of the area of the circle. So the area of the sector of circle is very easy to calculate. All you have to know is the angle here, and with the help of the angle you may calculate the area. In this book it is given in this radian form. I don't see it's so useful right now. I will turn to this later because there are some good points using radians in some cases, but let's go. Let's use degrees in this moment. So for example, if we have alpha equals 22 degrees and r equals 123 centimeters, then the area of the sector would be 22 degrees divided by 360 degrees times pi times r squared. We don't need those degrees there anymore, so we may leave them away. We may cancel them out. So this is very easy to calculate, and in this assignment 5, the first thing to find out is the you know here the radius of the circle, and you know this length here, and with the help of those numbers you may calculate the angle here. It is possible to use these right angle triangles there. It is quite easy problem, but you need to think twice before you start solving that. And let's calculate what is this. I will check it with another calculator because I don't trust that old calculator. Oh, it is okay calculator, but the buttons are so hard to use that I want to be sure to get the right answer. Yeah, it was in this case the right answer. If we round this to the correct accuracy, the starting values here are 22 degrees and 123 centimeters. So here there are only two numbers, 1, 2, and here are 1, 2, 3, three numbers. This is more inaccurate. This angle here, there are only two numbers, so the result should be rounded to the two numbers, and those numbers are shown here. And because the answer is the about 2,900 square centimeters, it would be rounded to that. Well, that was the sector of circle. Then there are other formulas also in this book and in that PDF I scanned from this book, but I will jump to the segment of circle there. And again, in this case, it is given in radian format. I don't actually like that formula. Let's take another book. I think this is better or more easy to understand, at least in my opinion. Ympyrän segmentti in Finnish. Let's draw that or write that name. Here it was called segment of circle. In Finnish, ympyrän segmentti. Actually, in this book of formulas, this Finnish book here, it is written together ympyrän segmentti, as there it was written ympyrän sektori without space there. But as you see, I wrote that word with the space here, and I think it is okay to use the space there or not use. Both are correct. For me, it would be, I would like to see their space, but I think this is maybe an official word for the part of the triangle. So this is the part where we have this part of the circle where we have this circle here, and we have here the segment. Let's draw a segment again. Sorry, sector of the circle first, like this, and then the segment is the part here. Maybe a little bit small picture. So it is like you had a cake, a round cake, and you cut a piece of it. Mostly it is I think it is correct to take this kind of part, maybe not this big, but this kind of sectors usually you take when you have round cake. But of course it is possible to cut it like that, and this part which is cut away, it is called segment. And if we have here r the radius, and here we have alpha, so the area of that segment, let's use this formula written in this book, r squared divided by 2 this is possible to derive this formula or prove this formula, but I'm not going to do that. It is not very hard problem. It is a it is a formula which is actually derived from this formula here and from the area of this triangle. If you subtract from this area the area of this triangle, you get the segment, and this formula is taken from that way. And so, for example, if we have r equals, let's take millimeters, and alpha equals, let's take only 5 degrees. So that is enough. We need to know radius, and we need to know the angle, and that's all we need to use in this formula. Segment r squared divided by 2. Actually, if we watch the formula for area of sector of circle, we had this alpha divided by the whole circle, or 360 degrees. And if we watch this formula, we have the same alpha divided by 180 inside of the brackets, but there is this division by 2 outside of brackets. If we multiply or move this 2 inside the brackets, it will go to the bottom part here, so it will give 2 times 180, that is 360, and that's exactly what is there. So we can see that there is actually the area of sector in this formula also. So this will be square millimeters. I will write the unit in the end of the, like here. I will use this calculator because with this I can see what I am writing. Yes, there was a question of these assignments. Not only the answers of the assignments, also the whole solutions in the form of PDF, or the PDF would be better, but also you can use photos and send them via email. So not only the answer. So in this case, we have quite a small area, because this was it was a circle which has a radius of about 1 meter. So the diameter was about 2 meters, but the angle was so small, it was only 5 degrees of this sector. And that's why the area was so small. Of course, in this picture also we can see that this area of segment is very small if we compare it to the area of the circle. So that was the segment of circle. Well, then there are some formulas. I'm not right now taking these. There are ellipse, and then there are parabola or segment of parabola. I think we will return to these later when we are going through some analytic geometry in this course. But after that, we have volumes here. So there are these kind of solid figures here, and let's take the most common formulas there. So volumes. Most common formulas for the volumes of solids or solids figures. Let's take the sphere first. Sphere of radius r. In Finnish pallo. If we take some words in which we have this pallo in Finnish words. For example, football. Actually, in Finnish it is jalkapallo. This is the not American football, but soccer. So there is this pallo there. Volleyball. Lentopallo. Lento means flying. Or if you are flying with the airplane or plane, you have this lento, you have this flight to the destination. And what else? Well, Finnish baseball, it is in this area of Finland we are living. This is very common. It is not the same baseball as they are playing in the USA, but it is a Finnish variant of that game. Pesäpallo. Pesä means same as base. I think there are many students in online group there who are used to the game of cricket. This is not in Finnish, there is not the word of pallo, but it is kriketti. I have to show that I have a cricket ball here in my home office. I sometimes try, many years ago I tried to spread the game of cricket here in my hometown, but there was not so big success. Okay, then the formulas for this sphere or the ball. And again, if we have the radius of the ball, we know. So the volume of the sphere is 4 divided by 3 times PR cubed. Volume, you can see the formula there from this book. Volume in Finnish. Yes, cricket is very famous sport in Asia. I know that this Finnish baseball is there is something to do with they are somehow belong to the same family of ball games, but actually it is played with another way. But this Finnish pesäpallo originates from the American baseball, and this baseball also have roots from cricket from long time ago. If you come to Finland, I would be glad to see you to play cricket if you can play that. I think they have earlier students. I think they have had some kind of cricket club here or actually I'm not in Seinäjoki right now, but in Seinäjoki they have played cricket. Well, example, again it is easy to calculate the volume with this formula. That is easy one if we only know the radius of the ball or the sphere. We can calculate the volume, but let's take the other way. We know that the volume of sphere is let's take the 589 cubic millimeters. Calculate the radius of the sphere. Well, um, okay, let's not make this any harder. We have this formula here. We know now the volume of the sphere, and we need to calculate the radius of the sphere. So let's start with this formula. We don't use the value of the volume yet. We will only calculate it from this 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 formula equation. So there is this division by 3. It is in the bottom side of the fraction, so we will multiply that away. We multiply by 3. We get 3 times 5 equals, let's put the dot there, 3 times v. I don't know what word did I say yes, 3 times v in Finnish. By the way, volume, the word volume in Finnish, I forgot to volume, that is tilavuus in Finnish. Tilavuus. Tila means it is like a space around you. That is tila, and this tilavuus, it means the space. As actually in this sphere, it is the space around the middle point of that or origin of that sphere. So we multiplied this 3 to the left hand side, so we have this 4 times p r cubed in the right hand side. And now we want to solve the r there, so we will divide this 4 times p or 4 times pi away. So we will get 3 times v divided by 4 times pi equals r cubed, r to the power of, raised to the power of 3. And as we did in this circle example, we had this kind of formula here. We had d squared there, and we got the d by using square root. Here we can get the answer by using cubic root. So we will use cubic root, and that means that we get the value of r, or the radius, by taking cubic root of the left hand side. I will write it in the correct order so that the unknown is in the left hand side. But so this, every time if you have unknown which has some kind of exponent there or power there, you take the same order of the root as is the exponent. If there is 3 in the place of power, then you take third root or cubic root. So now we will write the volume 589 cubic millimeter. So there will be 3 times 589 divided by 4 times pi. And after taking the cubic root of that unit, the exponent will be cancelled, so this will be millimeter. In this calculator, I may find the result immediately, I may write it is like in this in my paper. I will write it in exactly the same way to my calculator. Here I have, maybe you can't see it, but let's see, there is this second power here, and in the same button there is this square root. And this button here, that means anything exponent. For example, if I want to calculate 5 raised to the power of 3, I will use that button and then exponent 3. Well, 1, 2, 5 was the result. And in the same button with the red color, that is the square, that is the universal root sign there. So I may take that when I want to calculate this. So I will take with this red button, I will get that kind of figure there, and it is asking what is the index or what is the order of the root. It will be third root now, and inside the root I will write those numbers I have in the paper. 3 times 589 divided by 4 times pi. So now it is exactly the same as in the paper. And then we take the answer. Five times 5 point. Yes, quite a small. So this is dot 5.2 millimeters. Actually, I'm somehow surprised. But yes, it is it is possible, because this means that the radius of the ball or radius of the sphere is 5 millimeters. So here I have my ruler. So in this case, the ball is about this size. Very small. The diameter is about 10 millimeters. So probably the volume of that side is that big. Yes, it is easy to understand, because if we think this this is a sphere which has a diameter of about 10 millimeters, and if we compare it with the cube which has the side length 10 millimeters, and if we calculate this volume, it is 10 times 10 times 10, or 10 raised to the power of 3. So it will be 10 times 10 times 10, it is 1000. So the volume of this side of cube is 1000 cubic millimeters. And this ball or this sphere almost fits in this inside of this cube. Not totally, because this is a little bit more than 5 millimeters, this radius, but it is easy to understand this, that this is smaller than this cube, and as we see that it exactly is. This is only below 600 cubic millimeters, and this was 1000 cubic millimeters. Volume of cube is 1000 cubic millimeters. um, sphere, many times this is useful, the formula also, this area of the sphere. It is sometimes important also. Let's take that. Area of sphere. In Finnish, pallon pinta-ala. Pallo is sphere and pinta-ala is area. And this is 4 times pi times r squared. I don't know if you remember anything from differential calculus. I think you may have some course later in the university here. I don't actually remember your studies after my courses. I'm not sure, but in differential calculus, it would be quite easy to show that the derivative of this volume formula, if we derivate this, we get the formula for area of sphere. I will use my calculator to show. This belongs not to this course, but if someone has something, remembers something from differential calculus, so I will use. I have here diff and this 4. It is a shortened form of differential and integral calculus in Finnish. And then there I have derivata, which is derivative. And I will show you. I will differentiate this expression here. 4 divided by 3 times pi times r raised to the power of 3. So I will do differentiation or derivating here, and I press the enter button and I get the formula of the area of the circle. This is one way to remember those formulas, or at least if you remember the formula for the volume, it is easy to derive the formula for the area of the circle with the help of this. But that is not important in this point of studies. So actually, what does this mean, this formula? 4 times pi r squared. This is the formula for area of the circle. And where is that circle in this ball? It is that circle here which I draw there. It is the could be said called big circle of this sphere. So area of this area is pi r squared, and the area of the surface of the ball is 4 times that. It is quite, I think it's quite cute. Or is it? I don't know. This is a formula which, and also the formula for the volume of the sphere, you may use in at least in this assignment 6. This is not so easy, I would say. In my opinion, this is a little bit trickier than earlier ones, but it is not impossible to solve. But in this problem, you have to calculate the surface area and volume of this object, and this object is contained. It has a sphere there, and there also is this kind of figures there or solids there, which is actually the next formula we have in this book. So I will show you this right circular cylinder of radius r and height h. Right circular cylinder. In Finnish, it would be suora ympyrä lieriä. This right here means that it stands in the vertical position, so there is no angle here. It is straight upwards. It is right in that meaning. And this means also suora. It stands in the straight line, if I would translate this word. And ympyrä is, well, it is the circle. And this lieriö, that is cylinder. We also, in Finnish, we may also say cylinderi. So it is almost the same name as in English. Cylinderi. And again, there is this I letter in the end of the word. I think it is, for Finns, it is easier to pronounce the words if there are vowels in the end of the words, and that's why many times there. It sounds for a Finn, for example, this cylinder, well, it sounds strange because it doesn't end to the vowel. It's the consonant in the end of the word. And there we have mostly, yes, in this book we have the same letters. We have H stands for the height of the figure, and R stands for the radius of that circle. So we have this kind of figure here. So here, this is R, and this is H. And this is quite easy to understand this volume or the formula for volume, because we have this area of circle p r squared. So here is the circle, and also here in the bottom side of this figure or solid figure there is also the circle. And if we multiply the area of this base with the height of the figure, we get the volume. So it is quite easy formula. Volume equals pi r squared times the height of the figure. In this book, it was written in the same ways. There is also this kind of formula in this book, lateral surface area, and that means in Finnish we would say it vaipan ala, the area of, this is called vaipa, this well, I've been ill, so I have toilet paper here in my room. So this is actually the right circular cylinder, and this paper here, it is, this means the area of the lateral surface. Let's cut it from that point. So like this, I will take this area away. This would be the area of that lateral surface, and it is said here that it is 2 pi r times h. 2 pi r, that is the same as was the perimeter of the circle, 2 pi r. So the length of this borderline of the circle, it is 2 pi r. And of course, if we have here my stupid example of this toilet paper, I have this surface area there and open it. So the length of this paper, this is 2 pi r, because this is the circle which has a radius of r. So this will be 2 pi r, the length of this paper, and the height of the paper is the same as the height of this cylinder. So this is the formula for the lateral surface area. Let's put that into here. In Finnish it is vaipan ala. This word vaippa, actually in nowadays, if we hear in Finland the word vaippa, everybody thinks that it means the, is it diaper? Well, the babies who have they use, is it diapers in English? I have to check that, but this means in geometry, it means that the area of the surface, not the bottom and the bottom sides of this figure. It's only the if we think that this is some kind of wall, so we don't take the roof or the what is the word in English? I forget. I think maybe it's time to end this lessons, because I'm forgetting the words. What is the word in English? Let's take Google Translator, and this is the last thing I will do today's lessons. Floor. So this is floor, and then we have roof and floor. So we will eliminate those. So the lateral surface area would be only 2 pi r times h. Okay, I think this is enough for today. We have only one break today, so I think it's time to end this lessons. And I have tried to answer those messages you have sent today to me during these lessons. When we had a break, I answered some messages, but if you have something to ask from these assignments, or you don't know your personal assignments, so you can't start your calculation if you don't know your personal name. Can we get correct answer of first assignment, everyone has different answers because you have different the starting values for the calculation. So I can't give your answers. But if you send me your calculations, you don't have to be ready. They can be only a part of solutions. I can check those calculations to that point and maybe give you some advice how to continue that calculations. Yes, but okay, I think I will end right now, and I think we have to do tomorrow next lessons if I remember correct. So we will meet again tomorrow. But have a nice day and thank you for today. Bye bye.